Hi everyone! By the end of this video, you should be able to solve polynomial and rational inequalities and then write the solutions in interval notation. Before we move on to some polynomial and rational inequalities, it'd be helpful to remember general, let's say linear inequalities. So what I want you to do is write these problems down, solve this inequality, and graph this equation, and this will help us figure out what we're going to do when we get to some polynomial and rational equations. I'm going to pause the video. Please do this on your notes, and I will come back with the answer. Okay, if you solve this inequality, you should get x values are greater than or equal to 2. If you graph it, your line should look like this, y-intercept of -4, slope of 2. So the question becomes, what does it really mean to solve the equation where is 2x minus 4 greater than or equal to 0? So I'm going to plot the solution on this graph. So I only want the x values that are greater than or equal to 2. So here's 2. And I want the x values that are greater than 2, so that could be up here, 3, 4, 5, so on and so forth. So really, I want all the x values that are to the right of this line, which are all the values over here. Now I'm not going to shade below here because there are no values on that line that are down here, but in theory, all of that is greater than 2 as well. So what does it really mean to solve this equation? Well, if I'm saying where is 2x minus 4 greater than or equal to 0, remember that this is like my output. Okay, if I had 2x minus 4 equals 0, that'd be my output, which is kind of like your y values. So I'm really asking, when are my y values above 0? Which makes sense if you look at the graph. Now, when I'm at 2, I'm at an x-intercept. So x equals 2 would be the x-intercept of this. X equals 2, not 0. And then if I want the values greater than or equal to 2, I'm either going to be above or below the line. Since it's greater, well, the x values are greater, I'm going to be above the line. So when I'm really solving this equation over here, what I'm really asking is where are my y values, or where is the graph? Either way you think about it means the same thing. Where are my y values slash graph greater than 0 or equal to 0? So I'm asking where's my graph above the x-axis? For this problem, at least. I could ask below. Which makes sense. Because this is my y value, I'm saying when are my y values greater than or equal to 0, which is going to be above the x-axis. And the way that I would say my solution is my x values are greater than or equal to 2, or I could say anywhere from x is 2 to infinity. Now that 2 can be included because it's greater than or equal to, so I'd write that with a closed bracket here. Okay, let's take a look at a polynomial equation. I'm asking where is, this should say f of x. I'll rewrite that. So where is f of x going to be greater than 0? So same idea, this really means where are my y values greater than 0? Because f of x is kind of like saying y. So where's y greater than 0? Will be everywhere above the x-axis. So here's my x-axis. I want stuff that's above. Not on the x-axis, but above. So how would I answer that question or get a solution? The answer would be to find my x-intercepts, because that's where it would be equal to 0. Right here, 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 my y is equal to 0. But I only want the things above it. So in this problem, my x-intercepts are at -3. That's -1. And that's at 2. So where is it above the x-axis? Would be from -3 to 1. So that's this branch here. My x values are from -3 to 1, so it's above the axis at -2 and -2.5, everywhere in the interval. Okay, the other place that's above the x-axis is from 2 on. So that starts at 2, and my x values are going to go forever on after 2, so that goes to infinity. Now, I'm not using brackets in this case because we want y values greater than 0, not greater than or equal to. So if I'm solving a polynomial equation or a polynomial inequality, if I can get the equality greater than or less than 0 and compare it to 0, I can really just answer the question, where are my values going to be more than 0, my y values? This is pretty easy if you're looking at a graph or if you're looking at an equation that's already set equal to 0. If it's not set equal to 0, you may have to set it equal to 0. If you're not looking at a graph, it's a little bit more difficult. So for example, here's an equation. I want to know where it's greater than or equal to 0. I don't have a picture, so what can I do? Well, we know that it's going to be greater than 0 around the intercepts. Okay, so at the intercept, it's equal to 0. And then I can figure out, is it going to be above or below the axis? So in this problem, my three intercepts, if I set these three pieces equal to 0, will be -3, -1, and +2. Okay, I'm not plotting that too accurately, but you get the idea. To figure out whether or not our equation is going to be above or below the x-axis, I can just test points in each interval. If the output is positive, it'll be above the x-axis. If the output is negative, it'll be below the x-axis. So let's test something like -4, -2, and I'll do 0 and 3. So these are my intercepts in green, and my test points are in blue. Technically, you could pick anything in the interval. I just picked some easy stuff. So I'm going to go ahead and plug these points in, and if my y value or my output is positive, I'll say it's above the x-axis. So I'm going to pause the video. I want you to plug in all of these points and see what your output is, and we'll talk about it. Okay, if you plugged in each point, starting with -4, your output is -18. Your next output for -2 is 4. If you plug in 0, you get -6. If you plug in 3, you get 24. Okay, so if I get -18, that means my y value is below the x-axis, so I just wrote a negative here to show me that my y value is negative, whereas 4 is positive. Now, if you think about this equation, none of the multiplicities are even, so that means that if the multiplicity is not even, it will have to cross at that 0 instead of be tangent. So you should have a sign change if it crosses. So from negative, when it crosses, it becomes positive. So I go negative, positive, which you can test with the value. So if I plugged in 3, I'd get 24, and then that follows the pattern. Okay, so if I ask you where is this equation greater than 0, I'm asking where the y value is greater than 0. So that would be this interval and this interval. So those intervals are -3 to -1. Can't be included because it's greater than, not equal to 0. So my zeros are not solutions. And my other interval would be from 2 to infinity. So anything bigger than 2 should give me. And if you don't trust me, you can always test more points. So like test like +10 out here, just to confirm that that will be above the y-axis. Okay, now what happens if you're just given an equation? And this one is not a polynomial, this is a rational, but the same idea applies. In order to solve the rational inequality, we want to see where the values are either greater than or less than 0. And right now there's no 0 here, so the first thing you would need to do is get the set equal to 0 by moving one of the fractions over. So I can make this problem 4 over x squared minus 9 minus 3 over x squared minus 25 is less than or equal to 0. Now in order to figure out where this is going to happen, I need to find my critical points. So critical points are just, what are your intercepts to show where it's going to change from above or below the axis. So everyone to start by figuring out what are my solutions to this equation, what are my x-intercepts, and you would do that by solving the equation. So pretend for a second that this is equal 0, what would you do? So since we've already learned this, I'm going to pause the video and do that. I want you to pause and do it on your own, and then we'll talk about the solution. If you solve this equation for x, this should be your final solution. X equals plus or minus the square root of 73. If you need to go over these steps, please come and ask for help outside of class. But otherwise, basically what I did was I factored. I tried to cancel out the denominators by multiplying the whole equation by the denominators. So I distributed all of this out. This is a review of rational equations again. And then, these denominators would cancel with x minus 3s. These denominators would cancel with x minus 5s. So you'd have to multiply 4 by the x minus 5 terms and -3 by the x minus 3 terms, because that's what's left over. And if you distribute to 0, obviously it's still 0 on that side. Then I just got a quadratic and solved. So take a look at these steps, ask questions later. So these are my values at where it will cross the x-axis, which means if it crosses the x-axis, it's going to have a sign change. So we can figure out, when is this equation, ultimately we're going to look at when is it less than 0. So when are my y values negative? Now, I just wanted to graph this equation and just double check that. So here's one of my x-intercepts, here's another one, and those x-intercepts, you can check with your calculator to make sure the square root of 73 is 8.54, which it is, so I know I did that correctly. Now the real reason I graphed this inequality was to look at where our y values actually are less than 0. So if I look at my intercept here, when I go to the left of it, if I could get that to show up, my y values are going to be positive, very small but positive. If you go to the right of it, my y values are going to be negative. So our intercepts are really important to figuring out where our values are going to be less than 0. So the answer is to the left of them, they'll be less than 0. But if you remember rational equations, not only intercepts are important to sign changing, but we can have different branches. And the branches change whenever you have a vertical asymptote. So, although that they're negative here, they won't be negative forever because at the asymptote, we have a jump from negative to positive. So all these are going to be positive, so that can't be included in our interval. And here's another vertical asymptote, and then all of a sudden we have some negative values. So when you have a rational equation, you do need to check your intercepts for, what's going to be positive and negative, but you also need to check your vertical asymptotes. So in this problem, our vertical asymptotes are at x equals positive or negative 3, and also x equals positive or negative 5, because that's what would make my denominators equal to 0. Now the reason, again, this is important to check is your critical values, is because you will have a change in whether your y's are positive or negative on either side of the asymptote. So you need to check that. So, on one side of the asymptote, I've got stuff that's above and below the x-axis, but once I hit the asymptote, it changes. So I went from being below the x-axis, now I'm above the x-axis. So in order to actually answer the final question about where this graph is going to be less than 0, which again means where is it going to be below the y-axis, I would actually have to test all the intercepts and the asymptotes. So I would test negative 5, negative 3, 3, 5, but then I'd also have to test my intercepts, which are at negative square root of 73, which was like that negative 8-ish value, if you remember, and then positive square root of 73. So while that's a lot of intervals to test, I'd have to test negative 9, for example. Then I'd have to test like negative 6, and I'm just picking values of my choice. I'd test negative 4. I'd probably test 0 because that's kind of easy. Then I'd probably test 4, and then I would test positive 6, or you can even do 7. It's up to you. Then maybe I would test 10 instead of 9. I don't know. You'd have to pick points to figure out whether or not these intervals are going to be above or below the y-axis. Now, I have confidence in your ability to test those, so go ahead and test each on your own. Compare it to the graph, so if you have a graph calculator or Desmos, you can get out your own to find the answer of when this equation is going to be less than 0, which again means that it's going to be below the axis, the x-axis, because that's where your y values are less than 0. So to sum up, if you're going to solve a polynomial or rational inequality, you're really asking the question, when is that graph going to dip above or below the x-axis? So you'll have to get it set equal to 0 if it's not already done. Okay, so finish that final problem, write down all the questions you have, and I will see you in class to practice. Have a good night.